The next important concept is energy. Energy is a property of matter, and is the ability to do work. Here are some related concepts, including energy, work, force, displacement, motion, gravity, power, and machine. Energy is the ability to do work. Work is the energy transferred to or from an object via the application of force along a displacement. Force is a push or pull, it's to change the motion of an object. Net force is the combination of all forces. Displacement or motion is the change of position. Gravity is the force of attraction between all things that have mass. Power is the rate at which work is done. Machine is anything that makes work easier, like wedge, inclined plane, screw, lever, pulleys, wheel and axle, etc. There are also some related laws, like Newton's laws of motion, Newton's law of universal gravitation, and the law of conservation of energy. Newton's first law. An object in motion will remain in motion and an object at rest will remain at rest unless there is net force acting on the object. Newton's second law. The acceleration of an object is equal to the net force on an object divided by the mass of the object. Newton's third law. Forces act in pairs. For every action, there is an equal but opposite reaction. Newton's law of universal gravitation is a very famous formula, which explains the force between any two objects. Energy has many forms, which are constantly changing. The law of conservation of energy states that energy can neither be created nor destroyed, it simply changes form. The energy of the sun is the original source of most of the energy found on Earth. It's stored in different forms. There are only two primary forms of energy: kinetic energies and potential energies. Kinetic energy is the energy of motion, while potential energy is the stored energy. Kinetic energies include mechanical kinetic energy, thermal energy, electromagnetic energy, sound energy, and electric energy. Potential energies include gravitational potential energy, elastic energy, nuclear energy, and chemical energy. Here are some explanations. Mechanical kinetic energy, moving objects. Thermal energy, the total kinetic and potential energies in the molecules of a substance. Thermal energy always move from high to low energy. Electromagnetic energy consists of changing magnetic and electric fields, travels in waves and spans a broad spectrum from very long radio waves to very short gamma rays. It's basically light waves. Sound energy, molecules bumping into each other to transmit sound. Electric energy, the flow of electrons. Gravitational potential energy, stored in the height of an object. Elastic energy, stored in the compression or stretching of elastic materials. Nuclear energy, stored in the nucleus of radioactive atoms. In a process called nuclear fission, atoms are split and that energy is released. Chemical energy, stored in chemical bonds. Once bonds are broken, energy is released. Oil, gas, and coal are common sources of chemical energy. Now, you have better understanding of the two most important concepts in science, matter and energy. Einstein has established a very famous formula to relate matter to energy. In his universal formula, energy equals mass times the speed of light squared. On the most basic level, the equation says that energy and matter are interchangeable. They are different forms of the same thing. Based on that formula, atomic bombs have been created. Huge energy can be released from tiny matter. Here is how it works. Most things in the natural world can be explained by matter and energy, even for the Earth itself, or the whole universe. We don't know much about the universe, but we have some basic knowledge and models. Here are some commonly accepted theories, like stars' life cycle, galaxies, planets and moons, etc. Stars are the building blocks of the universe, with massive self-luminous celestial body of gas that shines by radiation. Stars are formed from nebula, a large cloud of gas and dust, through nuclear fusion. Stars have planets orbiting around them and those planets have moons orbiting around them. Stars will continuously lose its source of energy and begin to cool. Medium-sized stars will become giant, then white dwarf and black dwarf. Large stars will become supergiant, then an explosion called supernova, finally become neutron stars and black hole. The black hole is the leftover core of an exploded supergiant star. Galaxies consist of dust, gas, and millions of stars that are held together by their own gravity. The universe is made up of billions of galaxies. Apart from stars, planets, and moons, there are also asteroids, meteors, and comets orbiting the stars, which are pieces of rocks, metal, and ice. Gravity draws nebulas close together to form stars, causes space material to clump together, forming planets and moons, also causes planets to stay in orbit around the stars. This is the importance of gravity to our universe. Gravity is basically the driving force behind the origin of our universe, including our solar system. The planets want to keep moving in a straight line because of the physics of inertia. However, the gravitational pull wants to change the motion to pull the planets into the core of the stars. Together, this creates a rounded orbit as a form of compromise between the two forces. The speed, or velocity, of the planets plays a big role in their orbits, including the shape of the orbit. There are also some theories or models that yet to be proved. The Big Bang Theory describes how the universe expanded from an initial state of high density and temperature. The models describe an increasingly concentrated cosmos preceded by a singularity in which space and time lose meaning. This is not a bulletproof theory, just like the theory of relativity and superstring theory, but those are the favorite for science fiction books and sci-fi movies. Here is where those famous plots come from, like time travel, multiverse, teleportation, and space jump. General theory of relativity: the spacetime is a four-dimensional object that has to obey an equation, called the Einstein equation, which explains how the matter curves the spacetime. Superstring theory predict the existence of multidimensional brins. A Big Bang event occurs when two brins collide, producing a cyclic universe model. Quantum teleportation, transferring quantum information from a sender at one location to a receiver some distance away. Wormhole, a tunnel between two distant points in the universe that cuts the travel time from one point to the other. Unlike the universe, we do know a lot about our own planet Earth. We can also figure out what other similar planets look like. Here are some important facts about the Earth. The most important concepts include the theory of continental drift, global warming, and climate change. Earth's surface can be divided into layers. The innermost layer is the core. A part rocky and part molten layer called the mantle surrounds the core. The uppermost layer is the crust where we live. The theory of continental drift. The Earth's crust and the rigid layer of the mantle are together broken into large parts called tectonic plates. These plates move around on top of a plastic-like layer of the mantle. When plates collide or slide past each other, it can cause earthquakes and tsunamis. Earth also has atmosphere in layers: troposphere, stratosphere, mesosphere, thermosphere, exosphere. The ozone layer, which is in the stratosphere, protects us from sun's ultraviolet rays. Our activities have big impacts to Earth, and it will have big impacts to our future life as well. When humans' activities, like burning fossil fuels, release greenhouse gases, like carbon dioxide, they trap heat and cause global warming. As a result, ice caps are melting, sea levels are rising, forests catch fires, and there will be more extreme weather events and patterns. Other humans' activities, like landfills, pollution, deforestation, etc., also have big impacts to our Earth. Renewable energy, sustainable and circular economy is a new mindset for the future. We are also working on moving to other planets, like Mars, just in case.